Approximately 4.5 billion years ago, the Earth formed from particles left over from the creation of our Sun. Gravity drew these particles together to form pebbles, which then formed boulders and eventually the Earth. At its heart is a solid inner core covered by a liquid outer core. Above this sits the mantle made of flowing silicate rocks and a rocky crust. This rocky mass is the third planet from the Sun, orbiting the star from an average distance of about 93 million miles. It's close enough to the Sun to be warm, unlike the cold gas giants, but not so close that its surface is exposed to extreme heat and solar radiation, as is the case with Mercury. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe, particularly liquid surface water and life. According to one theory, much of Earth's water is as old as its rocks, both of which having formed during the Earth's earliest days. Because of Earth's unique distance from the Sun, the planet is able to contain water in all of its forms, liquid, ice, and gas, rather than have them permanently frozen or evaporated into space. But Earth is the only known place in the universe with liquid water on the surface, thereby having unique cascading effects on the planet. It hydrates the land, helping create nutrient-rich soil. It collects and pools to form oceans and freshwater systems. And it cycles upward to add moisture to Earth's protective atmosphere. And where there is liquid water, there is life. About 3.8 billion years ago in Earth's oceans, primitive life existed in the form of microbial organisms. They, in the ensuing billions of years, gave rise to a range of more advanced life forms that thrived in Earth's seas, lands, and skies. As the only world known to harbor life, Earth's biodiversity is expansive in nature. An estimated 1.5 million species of plants, animals, bacteria, fungi, and others have been cataloged, with potentially millions, if not billions more, yet to be discovered. Home to life and fueled by water, Earth houses a unique global ecosystem, as curious and as grand as the astronomical events that made them possible.
Countless planetesimals and icy planets bombarded the early dry Earth. Due to the bombarding water-enriched planetesimals, the Earth became enveloped by an ocean atmosphere system. Water vapor in the atmosphere produced rain, forming an ocean. The atmospheric pressure gradually decreased. The carbon dioxide-rich atmosphere transitioned into a CO2 ocean covering the water ocean. Carbon dioxide also combined with rock components and was transported to the bottom of the ocean through weathering and erosion. At this time, the ocean was still toxic with a high salinity and an overabundance of metals. It was too toxic to support life. The early Earth, when the atmosphere prevented sunlight from reaching the surface. Primitive life was about to emerge underground, in the cave of a geyser. Uranium ore emitted large amounts of radiation, creating a diverse range of materials and eventually producing the early building blocks of life. Water boiled and rose up to the surface, and the surface water flowed back down into the natural nuclear reactor. The temperature of the geyser water remained below 100 degrees, protecting the newly formed biomolecules. The underground environment was reductive, while the surface environment oxidizing. These conditions were necessary to synthesize biomolecules. In the Earth's Hadean eon, tidal forces were much more pronounced than they are today. Even lakes had significant ebb and flow of water, creating wet and dry cycles. These wet and dry cycles were one of the most crucial factors in producing the building blocks of life. Fatty acids came together, encasing the proto-life molecules. Polymerization progressed under the wet and dry cycles. Eventually, protein-like basic materials that could act as catalysts were produced. These molecules circulated between the geyser cave and the surface environment. The interactions of these materials led to more complex biomolecules. Proto-RNA combined with enzyme-like basic materials and evolved into ribozymes, which had the ability to replicate themselves. This laid the groundwork for life to reproduce. Finally, these molecules were enclosed within lipid membranes, forming primitive protocellular life. This was the beginning of life.